Welcome to this video. In this video we are going to learn about the small samples. When the sample size is less than 30, that comes under the small sampling. Under this we have first type, test the significance of a single mean. Here we are going to discuss about the students' t-test samples. Here we consider the random sample of n values x1, x2, x3, xn of a sample size n drawn from a normal population with mean and variance value. The sample mean is x bar, that is calculated by using this formula summation I varies from 1 to n xi divided by n, where xi is the sum of all sample values divided by n. N represents the sample size and the unbiased estimate of the population variance sigma square. Sometimes it is denoted as capital S square and its standard deviation is sigma. We define capital S square, that is our population variance, is denoted by the letter capital S, that is equal summation I varies from n xi minus x bar the whole square divided by n minus 1. Okay, for calculating S square, first we want to calculate mean of x, that is x bar, sum of x divided by n, and take the difference between them and squaring of that value is divided by n minus 1, sample size minus 1, we get capital S square. Next, the student test statistic is defined as t is equal to modulus of x bar minus mu divided by capital S divided by square root of n, or the denominator square root of n goes to the numerator in the form of product. X bar is the sample mean, mu is the population mean, and capital S is the variance, population variance standard deviation, and n is the sample size. For solving small sampling problem, we want to calculate the degrees of freedom. It depends upon the topic that is varying. The degrees of freedom for students t-test static is n minus 1. The degrees of freedom is denoted by the letter mu. Okay, now one note, small n into small s square. Small s is the sample standard deviation. If the sample standard deviation is given, means we want to calculate the n s square, that is equal to n minus 1 into capital S square, where capital S square refers the population variance. Here we have three categories for students t-test, okay, that are properties of t-distribution, second one application of t-distribution, third one assumption for students t-test. Now we are going to discuss the properties of t-distribution. Always the t-distribution ranges from minus infinity to plus infinity. Second point, the t-distribution like the standard normal distribution, and it is also represented as a bell-shaped curve, and it is symmetrical about the mean 0. Third point, the shapes of the t-distribution changes as the number of degrees of freedom changes, where the different degrees of t-distribution has a family of t-distribution. Hence, the degrees of freedom is nu is the parameter of the distribution. Okay, depends upon the degrees of freedom, the representation of a standard curve also varying. The variance of the t-distribution is always greater than 1, and it is defined only when nu greater than or equal to 3, that is our degrees of freedom is greater than or equal to 3 and is given as nu divided by nu minus 2. The t-distribution has greater dispersion than the standard deviation. As n gets larger, that is sample size is larger, then the distribution approaches to the normal form when n is as large as, so the difference is very small. Standard normal distribution compared with t-distribution when sample size is 5 and sample size is 15. These are the properties of t-distribution. Next we are going to discuss about the application of t-distribution. First point, test the hypothesis about the population mean. Second point, test the hypothesis about the difference between two means. Third one, test the hypothesis about the difference between two mean with dependent samples. Fourth one, test of hypothesis about the observed sample correlation coefficient and the sample regeneration coefficient. These are the types of hypothesis for small samples. Next one, assumption of students' t-test. Here we have three assumptions. First one, the present population from which the sample drawn is normal. The sample observations are independent. The population standard deviation sigma is unknown. Okay, the population standard deviation is sigma is denoted by the letter capital S here. If sigma is unknown means we want to use standard deviation of S. In large sample, first type is test the significance of single mean. Okay, that is in order to test whether the sample mean x bar is significantly different from the population mean mu are as follows. As usual, first we formulate the null and alternative hypothesis, that is H naught is equal to mu, that is equal to a specified value, and we set up alternative hypothesis H1, that is mu not equal to a specified value. Next we choose the level of significance. Obviously we choose 5% level. Here the test statistic formula is T is equal to x bar minus mu divided by small s divided by square root of n minus 1. If small s means sample standard deviation is known, we can use this formula, or population standard deviation is known means we use this formula, x bar minus mu divided by capital S divided by square root of n, where x bar is the sample mean, mu is the population mean, small s is the sample standard deviation, n is the sample size. Here capital S notation is the capital S represents the population variance, that is a standard deviation. Sometimes the capital S value given directly, or some data are given means we want to calculate capital S square, that is population variance value, that is equal sum of x minus x bar the whole square divided by n minus 1. After computing the test statistic, next we want to compare the calculated value with our tabulated value. Calculate the number of degrees of freedom, mu equal to n minus 1, that is sample size minus 1. If the computed value of t is greater than the if the computed value of t is greater than the critical value of t alpha, in that case H naught is rejected. If modulus t, that is calculated value of t, is less than tabulated value of t of the corresponding degrees of freedom at alpha percentage level, then the H naught is accepted. Here we have standard table for calculating the tabulated value. We can use the table chart for taking the 1% level of significance or 5% level of significance. Now we are going to solve some problem based on small sampling. Test the significance for single mean. Find the student's t statistic for the following sample values of a variable. The data are -6, -4, -1, -1, 0, 1, 1, 3, 4, 5. Discuss the suggestion that the mean of universe to be 0. Discuss the suggestion that the mean of universe to be 0. That is, our population mean value mu equal to 0. That is, the mean of universe is equal to 0. We assume as a null hypothesis and we set up alternative hypothesis, that is mean of universe is not equal to 0. Here the discrete data are given. Okay. First we want to calculate the number of samples. Here the number of sample is 10 and we want to calculate x bar. X bar is equal to sum of x divided by number of items, that is sum of x values divided by total number of item is 10. After getting our x bar value, next we want to calculate the x minus x bar the whole square for each value, each given datas. There is x bar, sum of x is equal to 2, sample size is 10, x bar is equal to 0.2. Next we want to calculate x minus x bar the whole square for each data. For 6 we get 13.44, for 4 17.64. When x is 1, x minus x bar the whole square is 1.44. When x equal to minus 1, x minus x bar the whole square is 1.44. Okay, like that and so on. Okay, after getting x minus x bar the whole square value, next we will calculate the capital S. Okay, we know the formula for the capital S is sum of x square root of x minus x bar the whole square divided by n minus 1. Taking sum of all these values we get 105.6 divided by n minus 1, sample size minus 1 we get 9. Therefore S is 3.425. Next we formulate the H0 and H1. H0 is mu equal to 0, that is mean of universe, mu equal to 0. H1 is mu not equal to 0. Next we set the level of significance. Here we assume the level of significance is 5% level, alpha is equal to 5%, and then we calculate the test statistic. That is T is equal to modulus of x bar minus mu divided by capital S divided by square root of n. X bar is already we know that, and mu is your sample mean value. X bar is the sample mean value, mu is the population mean value divided by capital S, that is population standard deviation, and sample size n. Now substitute all the values here. We get x bar is 0.2 and mu is 0 divided by S value 3.425 divided by square root of 10. Simplifying this equation we get answer 0.184 for calculated T value. Next we want to choose tabulated value of T at 5% level of degrees of freedom is here n minus 1. 9, that is degrees of freedom at 9 we have a table value for 5% level is 2.262. Okay, this table chart for T distribution. First column represents the degrees of freedom and second column gives the level of significance 10%, 5%, 2%, 1%. Now we set a level of significance for this problem is 5% level. Okay, now we can choose the 5% column and the corresponding degrees of freedom is our 9. Therefore, the answer is 2.262. Okay, the degrees of freedom is 9. At 5% level, we get the answer 2.262. Okay, therefore 2.262 for tabulated value. Now we compare the calculated value with the tabulated value. Calculated value is less than the tabulated value, so we accept H0. The mean universe is 0. Okay, degrees of freedom is 9. Give the conclusion. Since modulus of T is less than T alpha, the null hypothesis H0 is accepted at 5%. at 5% level of significance and degrees of freedom is 9. Okay, now we want to discuss the second problem based on small sample students t-test problem. A random sample of 16 values from a normal population showed a mean of 41.5 inches and sum of squares of their deviation from this mean equal to 135 square inches. Show that the assumption of a mean of 43.5 for the population is not reasonable. Here the given values are sample size n equal to 16 values are given and sample mean x bar is equal to 41.5 and in this question directly given sum of the squares of their deviation with this mean is equal to, that is sum of x minus x bar the whole square is equal to 135. Sum of x minus x bar the whole square is equal to 135. Next we want to calculate capital S, that is population standard deviation value, that is S square equal to summation x minus x bar the whole square divided by n minus 1, that is 135 divided by n minus 1 is 15, we get 9, therefore S is equal to 3. Okay, now we set null hypothesis and alternative hypothesis. Set up null hypothesis H0. Here we have to show that the assumption of a mean of 43.5 for the population is not reasonable. Okay, that is mu is equal to 43.5. That is mean height of population is 43.5 inches and H1 is mu not equal to 43.5 and we assume the alternative hypothesis is not equal to 43.5. Next we want to select the level of significance alpha. Obviously we choose alpha is 5% level. Alpha is 5% level of significance. Next we want to calculate the test statistic, that is x bar is 41.5 minus mu value 43.5 divided by 3 divided by square root of n is 16, that is minus 2.5 into 4 by 3. That answer is that is minus 2.667. Therefore calculated value is 2.667. Tabulated value T alpha at 5% level of significance of the corresponding degrees of freedom, mu is equal to n minus 1, that is 16 minus 1 we get 15 is T alpha is equal to, here degrees of freedom is 15. For 5% level of significance answer is 2.131. Now comparing calculated value with tabulated value of T, that is calculated value of T is greater than tabulated value of T. So we reject H0. So we reject H0. We accept the H1. Our H1 is mean height of the population is not equal to 43.5.